Quality scores are assigned for each base call when a sequencing reaction is complete. For these quality scores, there are different predictors which are calculated, and then they put them those predictors into some specific tables. What those predictors are, actually they are some specific properties which are associated with each base call. That may be like their intensity profiles, it may be signal to noise ratios, and they correlate these predictors with the quality of the base calls. They put these predictors into what they call them as Q tables. Originally this quality score started as Fred program was written it was written by Ewing et al. That is to be used in Human Genome Project. So over there they presented a scoring scheme which we call it as Fred scores. Here is just a piece coming out from a flowgram coming out from an automated sequencer, and we see that we have different color peaks, and at the top we have their Fred quality scores. So for instance, we can have in the middle line is the score of 20. So these bases have really good scores over here. These regions, they are poor, so their scores are low. So in this way, these corresponding peaks, we can look into them, and these can be used and converted into those quality scores. Fred quality score is the property that is logarithmically related with the base error probabilities. A high accuracy of Fred quality score makes them standard for sequencing quality, so they are used a lot. In the Fred quality scores, we represent the probability that a base is wrong as P, so that is the error probability, and we come up with a score called as Q, and this Q is represented by this equation. So it is related to the P as -10 to the log to the base of 10. So P is also related to Q with the equation down there, that is P is equal to 10 raised to power minus Q by 10. So Q is also known as Fred quality score. It is commonly called as Sanger or Q Sanger if we are fitting this equation, since it was written for the first time while at that time they have those automated sequencers that was doing these Sanger sequencing. So that's why they are represented as Q Sanger. Okay, so let's do a small exercise. So we do have a Q that is equal to 40. We are then looking into what Q score of 40 means. What is the error probability? So high score is correlated with low error. So let's see what Q40 means in terms of the error probability. So if we look into the equation, we see that P is equal to 10 raised to power minus Q by 10. So we put Q40 in it. We come up P is equal to 10 power 4. So a Q score of 40 is the probability which is 1 out of 10,000 base times 1 out of 10,000 probability that the base is wrong. Here is the Fred quality scores, and then in this chart we can see what these scores are. So low the score, there is the more probability of error, and as far as the base quality is concerned, that is low. So we have, for example, for the score of 10, the probability of error is 1 out of 10 and 90% is the accuracy. Let's look into 40. So we have 1 out of 10,000, so it is 99.99. So most of the sequencers, they are here. So the quality scores, they range from 0 to 40, and this is what is ideal. In Solexa scores, they have done a small modification. So rather than using the probability, they are using another parameter which we call it as odds. So odd is the probability of success versus probability of failure. So in this case, we can say it is P over Q. So P is the probability of error. So here in this case, it's the probability of failure. So divided by probability of success. So that is Q, which is 1 minus P. So the small substitution, everything is the same. In Q Solexa, we have Q is equal to -10 to the log to the base 10 of P over 1 minus P. What different sequencers are using, or what different schemes are there? What ASCII characters are used? What happens here is in this diagram we see that we have different schemes. So we have Sanger, we have Solexa, and we have Illumina. So Sanger is using Phred scores, and then it's adding 33 into it. So once we add 33, the first character they are using here is this one. So they use the characters from here, and then obviously they go up till since they are adding 33, and typical scores are 0 to 40, so they can go up till here. So these characters are mostly they are using. So typical score is here, but obviously you can have all of them. So they are using these all set of characters which are visible over here. X represents Solexa. So Solexa is using Solexa score, and then it's adding 64, and then the characters they are using is from here. So their typical score ranges from -5. So if you add 64 to it, it's 59. So at 59 we have this character, and then they move onwards. What about Illumina? So they use Phred, and then they add 64. So obviously they start from here and use these characters. So if you are using some softwares, you need to specify that quality scores are using which scheme. So that is an important task to do. So what so far we have seen here is that read quality scores are measures of reliability of a base call, and Phred quality scores are used as a standard measure.